Welcome everyone. Welcome to the fifth session of Connect University Autumn School on secure and sustainable digital infrastructures. I'm Alex, and I will be the host for the entire week. But today, merely warming everyone up for the main topic: data centers, can growth and greening go together? Now, we started back in 2015, actually, with Connect University, which is the knowledge sharing flagship initiative of DigiConnect, which aims to update both EU staff and you, the general public, on the latest digital trends, as well as important digital policies. Now, the scope of our session in general is to put at the same table EU institutions, industry, academia, and international organizations, helping us find inspiration from each other and identify current opportunities and threats to digital policymaking. Now, for those of you who are not yet connected via Slido, we invite you to do so using the code data centers. And I say this because over there you can ask questions, and we will make sure that they make their way towards the speakers. Also, if you want to share any insights on the event on social media, we encourage everyone to also use the hashtag ConnectUniversity and digital infrastructures. The recording of all sessions will be available as of next week. The links will be added in the chat, but feel free to already visit the Digital EU channel, which we will post everything, and as well the Futurium page, where we have a dedicated space for Connect University, where we also post everything. We invite everyone actually to join Futurium. In that place, we have communities for each subtopic relevant to digital policies, where we start discussions, where we plan the next meetings, and we see what's important for you at home. Now, generally speaking, technology moves pretty fast, so we must run alongside with it, and we want to have the best tools available to reach our destinations in good shape. Before we start the core session of today, I want to give you a small overview of the next destinations of this week in the autumn school. So after lunch at 2 o'clock, we will begin our session on Web 2 versus Web 3 towards the next generation internet. Thursday morning, we will start with a highly technical session as well on high performance computing and quantum infrastructure deployment in Europe. After that, in the afternoon, we have a session on industrial platform economy regarding Internet of Things. And finally, on Friday, we start the day with the mobile generation game from 1G to 5G and beyond. Lastly, we will end the week with a closing session hosted by our Director General Roberto Viola, who will give more of a holistic view of the week, of important weeks to take, their relation to policy, and also will give, let's say, insights into plans for the future of the European Commission, and as well as existing and future concerns of digital infrastructures. Now, as for our session on today on data centers, in order to give a more comprehensive context for you, and also shed some light on the topic for non-experts such as I, as well as for those of you more fluent on the matter, we have with us today Max Schultz, founder of SDI Alliance, Emma Fryer, partner at Environmental Resource Management, Miguel Gonzalez, head of unit in DigiDigit on data centers at the European Commission, and Manuel Mateo Goyer, deputy head of unit cloud and software. So without further ado, Manuel, please, the floor is yours.
Good morning, everyone. Good morning, Alexandru. Thank you very much. Today is the closest to the summit of my career that I've ever known, because I've always wanted to be a teacher at the university. So this is, I think, the closest I'll ever get. Thank you very much, Alexandru. If I'm a professor at the university, you are our rector. So thank you very much for putting today's session and the rest of the week together. I think we're all very, very grateful. Today is a university, so the ambition is more pedagogic, is about explaining what green data centers are all about, and giving you, and that's the part where I will be speaking at the end, a little bit of a policy perspective, but only a perspective, because it would take a full MOOC and not only a couple hours to do so. We've agreed among speakers a little bit to try to complement each other. We have 2 hours with a 10 minutes comfort break in between. So that leaves 20, 25-ish minutes for everyone. And we've agreed to present for 10, 12 minutes and then take 10, 15 minutes of questions from the Slido that Alexandru introduced a moment ago. I will be collecting the questions from the audience, and if the audience is too shy, I will make up for the questions myself. Voila, without further ado, I think it's time to start with the first of us four. Max, you will start. Max, you're the founder of the Sustainable Digital Infrastructure Alliance. I believe the best way to describe you is an NGO that works at making our digital economy more sustainable. I'm sure you will give more details about it. And since we're all behind our computers, I encourage you to open a side tab in addition to the main tab and the Slido, to go through the website of SDA, because they have a beautiful, I think the best way to call it is a technical roadmap of technologies that are needed to green data centers, but more broadly, digital infrastructures in general. Max, the floor is yours for 10 minutes, and then I'll come back with questions from the audience.
Thank you, Manuel. That was a very accurate introduction, and sorry for choosing always a name for our organization that is very difficult to remember, also for me, and to say out loud. So yeah, that was a very German, very efficient name. It expresses exactly what we do, but it's not very good to say. So good morning, everyone. Also, thank you for having me. I like that this is today a lot more about education, because I'm like explaining things and simplifying them. So I brought a little bit of a thinking model today to kick off the day that helps us maybe frame what is a data center, what's the role in the digital economy, and how can we think about data centers in a non-technical way, because otherwise technical, as Manuel said, then we need to write a book today. I'm gonna share my screen like this. So you're gonna see yourself for a sec. There. This should be fine. Yeah, good. I jump right in. So if we think about a data center, often what we mean is a data center facility to begin with. That's a building. It's simply a building on a piece of land. You can really, the way I always try to explain it to people is like an empty office building, right? You need a plot of land, you need water to build it, you need resources to build it, electricity goes in, you have embodied carbon, things like this. And inside the building you have not just walls, but you have also very sophisticated cooling equipment, you have sophisticated power equipment, you have backup power, and but at the end of the day, it's still a building. Now, one of the most important questions is, what does a data center facility produce? Without IT, and I'll get to that in a minute, a data center facility produces basically three things. Cooled space, so again, think of it like an office space, so a square meter that is nicely cooled. It produces highly available electricity, so from the grid, I might get something with 99% guarantee, but inside a data center facility, I get a lot more reliable power, and I get fast access to the internet. So that's the product of the facility itself. This model that you see here on the slide is what is often referred to more technically as co-location, but it is the same in an enterprise. If an enterprise has a data center facility and is renting it out to its internal IT departments, this is a facility. Now, an office building without furniture, however, is not so useful, and also without people working in it. So the second step is to move furniture into the office. And furniture, in that sense, is servers, network equipment. It's commonly referred to as IT equipment. And that IT equipment comes again with its own resource demands. So you need to produce the servers, you need to produce the network equipment, and it produces a new commodity because it uses the facility, the space, the power, the connectivity to produce a new commodity. My animations don't like me today. That we refer to as digital resources. It's factually a lot more complicated than this, but again, I promised as a simple thinking model. So you can think of it: a facility produces space and highly available power. You put in furniture into the office building, it becomes productive, and all of a sudden now it produces real office space where people can sit and work. And those digital resources are the same as an office space. In themselves, they are not productive. If there's nobody working in an office still, it's not productive. And these digital resources cannot be stored. So once they are generated, they need to be used. So if you look at this slide again, the business model that we know in Europe and the world that is very common to this picture is cloud infrastructure. It's also hosting infrastructure, so traditional website hosters, but also infrastructure as a service. That's facility plus IT equipment. Now, to the more interesting bit, I'm almost done with what is the data center educational part. So digital resources become productive when they're consumed by software. That's a very important one. And software, my slides don't like me, I'm sorry. And software is what is producing ultimately all these things that we have here on the right. So the digital economy, which is basically companies that only exist on the internet and do economic activity only on the internet, are completely built and run based on software. Digitalization of our society is the second really big thing, is all driven by software. And software is what consumes digital resources and makes these digital resources, puts them into productive use. This thinking model, so there's a facility, that's one actor, then there is somebody putting the furniture into the facility or the IT equipment into the facility, that's the second actor. And then there is software using those resources to build services and products. That's, I think, a very useful model to think and talk about this value creation chain. To help think about that even more, there is, there's a model that the SDA use. I presented it probably 20 times already, but it's always a good one. I still enjoy it very much. That we use to make it even simpler. So everything I just explained to you, we just refer to also in our name as digital infrastructure. So fiber, facilities, IT equipment, all this stuff is for us just one block. It's digital infrastructure. It produces digital resources. Those resources are being allocated by companies that are resource allocators or resource provisioners. For example, hosting companies, cloud providers, things like this. And then there is somebody building a software application that uses those resources or procures them and ultimately provides a product or service to the user. That's our macro model that we use to look at it, because once you look at it like this, you will see it becomes a lot easier to point at maybe some dysfunctionalities. The second thing we need to do is then talk about responsibility. So once you have this model that I just showed you, you can say like, who's responsible for what? And we start with the simple one. The user is, of course, responsible for sustainable use. If I have an electric car that's charged by green electricity, I should still not drive it in a circle. That would be irresponsible and non-sustainable use. And if I'm not using functionality in a piece of software, I should turn it off. Those are, in our view, the responsibilities of the users. Now, if I make digital products, so if I'm a software vendor or a digital product company or a software as a service company, my responsibility is to do that with the minimum amount of digital resource usage. You could compare this to the idea of energy efficiency in business. This is about digital resource efficiency. So I have to do this with as little as possible. The second one, and that's important, I will explain that later, is to make that the usage of digital resources transparent to the user, so that the user can connect their behavior and their usage to resource consumption. And of course, as a maker of software or provider of software, I also should source and procure sustainably made digital resources. The next layer, if I'm in the business of providing these resources to software companies, it is my job to avoid waste, because if I put lots of IT equipment in a facility that's running 24/7, it's producing resources. If I'm not allocating those efficiently, then there will be a lot of wastage, and that's it is the responsibility of the resource provisioner to reduce that waste. And lastly, and that's also where what Manuel mentioned, our roadmap always comes in, is you need digital infrastructure that is capable of producing sustainable digital resources, which is, you need a plan on how to do that, and that's our roadmap. But all the other functions here are equally important. Now, in terms of sustainability, which is a more complex field, there's two leverage points that we always look at in this model. But today, on the second one, I will let Miguel and the others and Emma talk about, so to say, what's happening there. So I'm just going to focus and give you three ideas on the software part and the resource provision challenges that we see. And who knows me knows this will always come. It always, for me, it always starts, but I have a background in software engineering, so it's probably logical. It always starts with gathering evidence and facts and having transparency on the environmental impact of products. So it will always start with measuring. And I brought this one example that I was presenting actually at Mercedes-Benz, and it was came to me how we can connect these two words. If I don't have transparency as the user, using, for example, this WebEx or using a note-taking application or using a CRM on how much my usage is creating an environmental impact, it's very difficult to change my behavior. And the example on the right is an electric car. If I'm an aggressive driver and I push the pedal very hard all the time, I can immediately see how I'm draining the battery. I can immediately see how that's affecting the health of the battery. And I can basically see how I should be driving differently. The car is really suggesting it and helping me make that decision. And the mental model is the same. In the digital world, we need to be able to associate, we need to have enough transparency to be able to say, when I do this in the digital world, when I upload, 100 minutes of video on YouTube, what's the environmental impact of that? And that transparency is really key, especially on a usage level, so that we can basically, that we can know and change our behavior. The second one is a bit more complicated, but I hope you come with me. If I build software applications and I want to make it transparent to the user what the environmental impact is of their usage, I know I'm consuming digital resources. So for each unit of digital resource, I also need to know the environmental impact, because then I can simply make a very simple calculation and show the user, you consumed this many resources and this converts into this much environmental impact. For that, we already have standards and models, which is the Lifecycle assessment framework that's standardized both in the European Union and in worldwide in the ISO. And it exactly says how to do that for a physical product. Of course, digital resources are not physical products, they're digital products or digital things. So we have to adjust it a bit, but as if you know the STA, we've published a few papers that this is definitely possible. And then every provider of resources needs to basically attach this information to every unit of digital resource that is being sold. And this is not just cloud providers, because that's often what we all think about, but it applies to everybody. Every resource provisioner in Europe would have to do this, to attach this lifecycle information to each digital resource they sell. That would be very powerful to help make this usage transparent and then also drive behavior change. Now, the third one, and that's a bit more complicated, but we're trying, is that there is still, to basically make an assessment of a digital application or software, there is no standardized methodology. There's a lot of people around the world, and especially in Europe, trying to do that, to say, look, this product has this footprint or has this much environmental impact. And we're not even at the social impact step. That's even more complicated. And at the SDA, we have been trying for some time, and I think quite successfully, to bring everybody together and to really focus on making one simple, applicable methodology to create, to basically assess the environmental impact of software. And most of the logos that you see here, they are now part of a group that's working together to make that happen, because we believe it's quite important for the transparency aspect to know that we all do it the same way. Yeah, that's it, actually.
Professor Max, this was excellent. Actually, very pedagogic, and I learned myself many things. And it's not the first time I hear you, but there were still a lot of new things for me too. So there was really no sense of repetition. A few questions coming in the Q&A on Slido. And I'll regroup them a little bit. There are two questions that boil down to the same argument, which is putting the burden on the user is a bit difficult, right? Who are we as end users of IT equipment to have an effect? What is our, how can we turn off functionalities of the software we use on a daily basis? It doesn't seem to be something really within our reach. Can you elaborate a bit on this?
Yeah, I can see how that comes across like this. So it is not our intent, and I also completely agree. It is not the user that is, so to say, who needs to make the biggest adjustment. I think that's not correct. But there is this idea of society needs to, we call it, I think, political will. We need a lot of people to be at least aware of what's going on for us to take systemic action. And so for me, it's less about shifting the responsibility to the user all the way, but to create transparency so that the user says, hey, but I'm not sure if we want to spend so many resources and energy right now on this website, right? That it enables us to question what's going on as users.
So thanks a lot for the response. So we understand it's a broad concept, and part is political, but still, as an end user, is it relevant to, for example, link instead of enclosing attachments? Is it relevant to delete instead of archiving? I mean, are there little things that end users can actually do, and are they significant?
At scale, all of them are significant. So I think, especially the two that you just mentioned, so deleting things, yeah. So not using a computer as an infinite archive of information is absolutely useful. I think if it's contained on the same device, then using the device to 100%, so filling the storage to 100% is okay and makes complete sense, because the energy use of that is pretty much the same. But if it's cloud-based or server-based, if it's somewhere in a data center and I can't see it, then I should always assume that deleting things and reducing the amount that is stored there or the amount that is computed there will have an impact.
Okay, good. So I know what to do with my thousands of pictures gathered throughout the years. A separate question, Max. You explained the different roles of the different actors in a data center, to put it like this, and I think that was very insightful. But there was no mention of security aspects. How do those different actors distribute the security responsibilities among them?
Yeah, I think there's the. So I always navigate a bit away from security because it is, of course, a very difficult topic. I think there is the view how it wants to be seen. So ultra high security, nobody can actually enter these facilities, especially people from, so to say, the non-infrastructure side. But in practical reality, if a lot of people are inside the data center and a lot of people can go in and out, and it is not it's not necessarily that sophisticated, but if of course it's a military grade or government grade data center, that's different, right? If we're talking here about commercial data centers, then security is tight, but it's not impossible. And yeah, I think everybody plays a role, but the challenge is if you hacking the physical infrastructure or accessing that is completely different to I can take over all the servers in a data center and the physical infrastructure won't even notice, right? So there's different ways how you can attack, and each of these actors has a completely separate responsibility to protecting their part of the chain from takeover or from hacking, basically.
Okay, so there's a difference in between the physical security, accessing the servers, but then segmenting the use and applications and how it all operates. Another question: you developed the software dimension of the for energy efficiency purposes. Can you tell us a little bit what has been the history of software development, and in that respect, in that sense, over the last 10 years? And there's a sub-question associated to it. What is it with a blockchain? Is it a significant impact? Is it changing? How does that come into the picture?
Yeah, I have actually another slide pack where I do that one. So what has happened in the last 10 years of IT, and I actually, before I did the SAA, I still worked for almost 15 years in IT, so I've seen it happening in real time, is abstraction upon abstraction upon abstraction. So we had virtualization, which was, we don't know which server our software is running on anymore. It could be hundreds, could be one, could be 10. Then we had containerization, which meant, okay, now we're going to split the application into lots of little pieces and they're going to float everywhere in the data center. And then came the biggest irony of IT, serverless, which still runs on a server, but it's even tinier pieces of computation. And so we are trying to make the compute, the work smaller and smaller and smaller so that we can shift it around in a different way. And that would enable things like decentralization and things like this. Technically, I think we're still very far from really actually moving things. We are just trying to concentrate more work per server. That's still the problem that everybody's addressing. But this abstraction has also given rise to this notion that I don't know anymore what my real resource consumption is, especially in the cloud-like technical environments. It's very difficult to actually assess how much servers am I really physically using under the hood, how many data centers am I in, I don't know. And to the magical question of blockchain, blockchain is a technology. There's a great sentence in tech that I use a lot. A blockchain is a technology that is still looking often for its problem. And that's how I look at it. This is the same for me with 5G. If I talk a lot about sustainable 5G, sustainable 5G is just staying at 5G and not going to 6 and just doing more power, doing more network capacity with the same equipment. That would be great.
Okay. Thank you very much. A couple of final questions because the time is running. So there's several which are not necessarily linked, but your comments on which I actually induced you into, but maybe you can further elaborate on deleting things. I think that has sparked several reactions. How can we delete things? That goes against the business models that that the user, or rather that the service providers are putting on us. And simply, how does it help to delete things? So that's one question. There's another question about maybe to summarize, and this is very factual, the different names of the different business models around data centers, so hyperscale, colocation, etc. And then a question which I'm not sure you intended to say, but a listener hints that you made a difference in between efforts from European actors and American actors when it comes to energy efficiency. So I'm not sure this was your intention, but maybe you can comment on that. So those are your three final questions.
Thank you, Manuel. On the first one, so I find it always it's amazing because you can use energy to a certain extent. Nobody would ask the question, why should we close our windows at home when the heat is running? Or why should I turn off my lights when I'm not at home, right? That's those you would look at me and be like, yeah, obviously. But in the digital world, it is somehow assumed that just storing things infinitely has it doesn't mean anything, right? So I think the question about deleting things is really simple. Of course, everything has a footprint. So yes, should use the resources that we have as efficiently as possible. So let's not waste it. And you're right, though, and that's something also I've said many times, is the business model of infrastructure, same as a utility, is to sell more resources, right? So they will never come to you and be like, hey, why don't you delete all this? Or do you still need the server? Nobody's ever going to do that. Or utilities also not going to come and say, could you please turn off your fridge? It uses too much power. It's not going to happen. But that's why, for example, utilities we regulate to make sure that they don't come to your house and sell you more fridges all the time. So the business model is, of course, tricky, and we need to be aware that that's not in the interest to turn anything off. Manuel, remind me, what was the second question?
Sorry. The second one was the vocabulary of the different business models, colocation, hyperscale, etc.
Yeah, so I'm very deliberate as always how I describe these things. So for me, there is the facility level business models. So there's co-location most of the time, wholesale and retail, so small pieces and big pieces of space. There is then the layer on top, which is there's a few business models there. Hosting is one very common one. Managed service providers or IT infrastructure providers are another. That's very traditional, local, regional shops often that you buy your Office 365 license maybe from, or Nextcloud or something else. And then you have, so to say, cloud, which is a different form of hosting, cloud infrastructure. And I don't refer to it as hyperscale because you can provide cloud infrastructure with a non-hyperscale facility. That's why I'm also always a bit careful. And everything on top for me is digital products and services. So what makes it sometimes confusing is that a lot of the big cloud providers do all of it, right? You can rent space, you can buy just resources, you can buy services, and that makes it a bit difficult to say what are they. But they are cloud infrastructure providers with services on top. That's how I often look at it.
Yes. So it's really not a single classification, but there's different ways of classifying them. And there's another classification that or name that you see very often out there, which is public and private cloud, right? Where it's not private sector and public sector, but it's rather public cloud being things that are commercially available to anyone, and private cloud being something that is captive for your own needs in your own organization. So So yeah, and the final remark was about this American versus European efforts. I'm not sure it's something you actually said, but that was the perception of the person asking.
Yeah, I don't think I said it, but I do. I've always had this view that if you really look at the technical execution of hosting companies and co-location companies that are European born and that have been European for a long time, they often have already implemented a lot of innovation that now Manuel often is asking for. Take liquid cooling or refurbished hardware or recycling hardware. There's a lot of good examples of that. We already have that. And I think that in comparison to the US, they relatively late to that game, actually, of providing hosting infrastructure. And they do it in a lot more hyper scale. So a lot bigger facilities, and they reap efficiencies through the size, through the scale, whereas there's a lot of European actors that reap efficiency through, so to say, technical changes and innovation in the facility level, and I think that's often under-recognized, in my opinion.
No, that's an interesting thought, which I'm sure if we had both sides around the microphone, they would argue. But I take away a positive outlook that we could get the best of both worlds if everybody would learn and build on each other. Thank you very much, Max. This was extremely insightful, and I think openly frank about the situation and the panorama. So stay with us in idle mode, as they say in data centers. We might come back for questions for you if anything pops again. I'm now turning to our second professor, Emma. Emma, you were, I think, rightly introduced as a consultant for ERM, but I think what is relevant is first that you're a consultant in advising data centers on how to be greener. Correct me if I'm wrong, but even more relevant is what's in your CV before that. You've been working in this area for many years, notably within Tech UK. So the Digital UK Association, where you've been leading these developments of green data centers, and if I may add, you're as well, I think, one of the shiniest. I'm not sure the word exists in English, so I'll go with a literal explanation of the ones who make things easy to understand. So data centers and sustainability, the floor is yours, Emma. Your microphone is off, or we don't hear you. Still not. Still not. Alexandra, can
you are also muted.
Yeah.
Yes.
Thank you. I couldn't unmute myself.
Now you're on.
So I failed at the first technical hurdle. So yes, my job is usually trying to explain technical matters to non-technical people, of which I clearly am one. So I'm sorry about that. I should have unmuted before sharing, and now I have to work out how to unshare at the end of this, which will be another challenge for me. Can you see my slides? Excellent. So that's number one. Let's have a look. And am I in the right? At the moment, I'm on a different. Let's have a look. I seem to be on a different slide from the from where I'm expecting. So bear with me a second. That's not. Hang on. Right. And hopefully I'll get back to the beginning of my slides. So we're having. I might come out of sharing and share again. Just a second.
You can use your left and right arrows to move through them.
Yes, it wasn't moving, so I think I just shared the wrong application. I'm going to share content this time, see if that works. And it's for some reason I'm not in the. So take me a second. Right, and it doesn't. Yeah, I'm not going up and down at all. Hang on a minute. Let's try again. It worked perfectly when it right. Can everyone see that or not?
I'm
Or am I
afraid
seeing
not,
you?
Sema.
Okay, let's try again. Right. Are we
It's
good now?
starting. Yes,
Yes.
we're there.
Yes. Okay. So, right, as I said, my job is trying to explain technology to non-technical people. And I was going to say I am not technical by background, but I think I've illustrated that amply now in this. So, yes, and I'm delighted to be back. I was here last year and we had a great session last year, which I really enjoyed. Yes, I am now with really looking at how to help data center operators address their sustainability challenges in reality and in detail. Before that, I spent 10 years at Tech UK providing a collective voice for data center operators. So I know what keeps them awake at night. So that's really where I come from. And obviously, it's been an interesting place to be. It's a fast-growing and rather secretive sector, and sitting between that and policymakers who needed to understand and scrutinise it better was quite an interesting place to spend my time. Now, am I going? Now I've got to move on. Excellent. Okay, so I'm just going to recap, and I know Max has covered some of these things. So we've got a number of issues going on. We've got a huge increase in demand for digital data and digital services. The sector's undergoing rapid growth. We are improving efficiency. We're not quite keeping up with this explosion in demand, but we are keeping energy consumption surprisingly low in the face of a 20-fold increase in internet traffic over the last 10 years. Our operational decarbonisation is well ahead of the decarbonisation in terms of embedded. So we're good at operational. And awareness of data centers is growing, but not always in a good way. So I think we're doing quite well, but there's no room for complacency. And I just wanted to flag the two slides on the right. One of them is showing the growth in data center capacity, and that's co-location. And there is that does matter. That's a certain type of third-party service provider, as Max explained. The chart below is quite a useful one from the International Energy Agency that I know I put up last year, which just shows you the little green line at the bottom, which looks very flat, is the overall data center energy use, which is very flat, and there are reasons for that, compared to the growth in data traffic. That can't stay flat forever. And it's mainly flat at the moment, we think, because there's so much embedded old capacity, data center activity, or rather IT activity sitting on premises. It's very efficient, and as that is outsourced, there is headroom. But anyway, so that's where I think we are. What I wanted to look at were the drivers for sustainability. What is pushing an operator to ensure that their environmental performance is improving? And I found 8. So these are the 8 I found. I'm going to go into each of them in slightly more detail. So, so those are my headings, and I'm going to start with policy. So policy and regulation, in fact, I'm going to start with policy, but I'm not going to say much about it because Manuel's going to cover it in much more detail. But what I'm seeing is that the policy and regulation is a huge driver of sustainability in data centers, even though in some ways data centers have only been explicitly recognized as a sort of target for policy in the last few years. What I'm expecting to see there is much better transparency, accountability, and reporting across the value chain. So it'll be interesting to see whether what Manuel says at the end agrees with what I've said here in principle. The next driver is what we call it in the industry power provisioning, which sounds quite fancy, but it's just power availability. Data centers like to develop in clusters. And when they do that, we get new sites in the same location, and we start having power constraints. So there's certain places where there just isn't enough power to go around. And what that does is it forces operators in two directions. One is to start looking at alternative renewables and other ways of looking at power. It also forces them to think about locating data centers elsewhere where there might be plenty of renewable supply. So it makes people think a bit differently. Then I've got voluntary initiatives, and these have been really effective actually in driving energy stewardship. The EU Code of Conduct has been around for a long time, and that's developed a number of technical best practices, which have since been adopted as the basis for a number of bespoke data center standards. The Climate Neutral Data Center Pact, that was set up a couple of years ago in dialogue with the Commission, and the aim there is to try and address some of the big concerns about data center sustainability. So it's looking at things like efficiency, renewables, water, circular economy. That is doing something that's quite hard. So it's working on some very difficult projects to try and develop metrics for complex scenarios. So I'm really pleased to see the progress there. And then most recently, the infrastructure masons, which is kind of network of the people who run essentially the digital infrastructure, they have committed to essentially account for and report on, in a standardized way, embedded emissions. So that's a really useful development, I think, which we haven't seen before, better scrutiny of the supply chain. So I think that's, those are really exciting drivers, and the engagement in those initiatives is really high. We've got very big sign up from the industry. Then we've got public perception. So there was never a problem with data center developments when they were in sort of obscure industrial estates on brownfield sites. But as the sector expands, we're seeing developments now being much more visible to communities, and communities are wondering, what data centers do. So I think that this is driving operators to think more carefully about how they engage with those communities to ensure that they can deliver what we call a community dividend. And also, I think there's a need, and I'll come on to this later, for more of a sort of maybe a slightly more formal social contract between citizens and data centers. I put up 8 drivers at the beginning, and I've gone through the first 4, which were policy, power, public perception, and voluntary agreements. And the other 4 are more straightforward, so I just thought I'd run through them quickly here. So one is customer demand. That's been incredibly effective in driving renewables uptake. If your customer wants that, they're going to get it. And we're also seeing better public procurement in terms of sustainability requirements. Investor requirements are another thing. We're seeing a huge change of pace there in terms, and certainly in terms of some of the requirements like TCFD, CSRD. That's going to make another step change. And then just internal targets and commitments and how companies want to look in terms of the leadership positions they take and their reputation. Those 2 are quite important drivers. And then I just wanted we're going to talk a little bit about this in practice, because I know we're covering this in actually what's happening in a data center later in this session. But these are some of the things that I'm seeing operators looking at. So hydrogen, fuel cells, different kinds of fuel cells. They're trying to make data centers hydrogen ready, and operators are looking into the production of green hydrogen. Lots of interest in industrial scale battery storage, which would enable load balancing. And it might wean us off some of our diesel generators. Within the data center, we're looking at a lot of AI-assisted cooling solutions. Lots of interest in the sector on biofuels, although there are, that reduces the carbon impact of diesels in the standby generators, but it doesn't do that much for air quality. And also there are supply chain issues that we've got to bottom out, so that's not without problems. Microgrids are really a way of giving us better control, operators better control over their energy supplies. But the last one is most interesting to me. This is a part of West London. That's a strategic partnerships tab in the bottom, where the operators are working with the local planning authority to strategically plan in heat reuse and other forms of sort of actually power sharing, using the energy that's been provisioned there more intelligently among multiple users. And I think that's a really interesting case. As I said, we can't be complacent. So there are a number of challenges facing the sector. I thought Max brought up some of these. One of them is the fact that we get more and more efficient, and because the use of digital services is price elastic, everybody uses them more. So the demand goes up, and that's why we see those big escalating demand curves. We get more efficient, it gets cheaper, we do more of it. The second one is that data centers are resource hungry, so I think we need more focus on circular economy. Material scarcity is a real problem, and we're watching e-waste heading in one direction around the world, and materials going in the opposite direction. So I think we have to look at that really carefully. And then again, these common consumer-facing business models tend to be freemium or advertorial or all you can eat, and they don't give a signal to the consumer. And that's exactly what Max said about his electric car. We're not seeing that we're given an indication of the carbon impact of our internet activity. And then I think data centers need to think more carefully about social performance. But I also think that's a two-way street. So when I mentioned a social contract earlier, this is really what I was talking about. So I think here that operators cannot assume that they have a social license to develop, expand, and operate these large facilities. They have to engage meaningfully at local and regional level. But actually, there's a quid pro quo to this, because actually everybody else has to recognize that the internet underpins our daily lives, and it needs industrial scale infrastructure, and that needs energy. And my underlying of this is that you have to recognize that the internet is run by physics and not by magic. There's somehow a sense that it all runs by magic. It absolutely doesn't. I've got a little coda, so I hope you'll indulge me a bit. I don't know whether this is just limited to people who were brought up in 1970s England, but here we go. I don't know if this phrase means anything to anybody. If I then outline the acronym that you get from this, may give some people a clue, but not many. If I show you this picture, a few more people may know what I'm talking about. This is a TARDIS, but the TARDIS, it looks a 1970s police phone box, but it's not a phone box. When you open the door of this TARDIS, it gives you access to something that's so much bigger and more powerful than a phone box. Behind this unassuming facade is a powerful portal. In fact, the facade is a powerful portal, and it gives you limitless access to travel through time and space. So anyone who watched Doctor Who in the 1970s, or actually more recently, they will recognize that TARDIS. Now, you may not recognize a TARDIS, but I'm sure you recognize this object. This is a smartphone. But a smartphone is not a phone. It looks like a phone. This device is a portal. This is a door to a big data center, to many data centers, and to the whole of the network infrastructure that connects them together to make that wonderful thing, the internet. And you use your phone to travel through this limitless space of the internet where you can access pretty much anything you want without leaving home. So my sense here is that your smartphone is a TARDIS. And I think you have to remember that when you use your smartphone, you are using a data center. That's what you're doing. So I don't know whether my question got onto Slido at the beginning, but my question was, how many times have you used a data center this morning? And it's equivalent to how many times you use your smartphone, because I don't think you use your smartphones now. I certainly don't very much to phone people. So that's really where I'm going to leave it. Any questions? I think we've left some time for that, Manuel, and then I'll work out meanwhile how to unshare my screen, which may take me a minute or so.
Thanks a lot, Emma. And the Doctor Who, how to put it? Yes, it's not for the youngest among the audience, but I'm part of the oldest one, so I relate to it, and I wasn't expecting such a comparison. So thanks a lot for this, Emma, and thanks a lot as well as with Max for your honesty. Quite a few diverse questions to you, so it's going to be difficult for me to gather them. But let me bring them as they appear on my screen. The first one, I think, elaborates a little bit on the user-oriented questions that we had with Max, and it's are there any tool out there for the end user? And I think it's end user as a citizen, but as well as a business using data centers to measure your footprint. So say I'm the bread shop around the corner, how can they know their online accounting, what's the footprint of it? And as an end user, the storage of my pictures online, or the streaming of my web streaming videos. Are there any tools out there to measure your own environmental footprint?
It varies. So I think, and Max, do feel free to chip in. So the large hyperscalers, for their customers, they do tend to provide that. So we're seeing a sort of carbon calculators being provided so that customers can have a feel for it. But I think they tend to be quite black boxy, so it's not a simple tool. There've been people who've been developing. I think Dimpax has been working on developing tools that are more sort of at the consumer end. There are also rules of thumb, because a lot of this stuff you can find out. And last year there was a very good report by the Carbon Trust, for instance, on the carbon impact of streaming. And therefore you can get a good feel from that report what your streaming habits are and how you can mitigate them. And interestingly, it's not so much to do with how much you stream, but the user device it's on. That's what and also the energy profile of the country that you're doing that activity in. So that makes the biggest difference. If you're streaming on a phone, it's I think 1/90th of the power overall than if you were using a sort of huge screen. So that's it. What's surprising about it is what makes the big difference. What I am seeing though is a huge amount of interest in developing those kind of tools. And Max, I would imagine you're much further ahead on knowing the technicalities around that, because I don't. But certainly large customers, the big providers are trying to do it. If you're a very small customer, you've got to, or rather you're in a small cloud provider who's just doing one layer of the service, they may well be able to tell you that, and some do. But yes, at the consumer level, it's more tricky, and you probably have to work by rules of thumb.
Okay, thank you very much, Emma. Two interrelated questions. I think the flagship question is, how does edge computing affect the future of the data center business model? But we'll limit it to the environmental aspect. So does edge computing affect the environmental equation? And I'll combine it with someone else who says, okay, if data centers are so, centralized data centers are so complicated and energy intensive, why don't we all have our little data centers at home? And I think that kind of relates as well to these questions of more decentralized facilities and edge. Can you comment on those aspects?
I can try. That's like a whole other area. But yes, it's a great question. So decentralized IT traditionally has been super inefficient in cupboards and server rooms. So that's what we're trying to consolidate. And by consolidating that, what we call legacy on-prem is the phrase we use. By consolidating that, you can actually improve efficiency by about 2 orders of magnitude. It's incredible what you can do. That's distributed IT. In terms of that model is not edge. So edge computing is where you put the computing function near to where it's going to be used. So edge is going to be critical for applications like congestion management or autonomous vehicles, because you need this what's called ultra low latency, very, very quick messages. The message can't, between 2 cars about to crash, it can't go back to a data center in outside the country and then come back, say, right, you need to brake. But a lot of that information doesn't need to be stored, is my understanding. So that there's no storage function, it's instantaneous. The other thing about edge is that and again, Max, feel free to pile in here, is that the business models that will depend on it will require those mini data centers to be super efficient, or I can't see how the business model will work. So I think there'll be a market control on that. From my point of view, which always used to worry me, is I was always trying to count up data centers and how much energy they use, and having the consolidated model helped me a lot, because it helped me get sums right. And my concern, if I'd been in my last job, would have been about, right, now we've got all these little distributed data centers, how do we add up that power in a meaningful way? How do we account for the power of the sector in an aggregate way? And that's not actually an operational problem, but it is a problem if you're trying to look at the sector as a whole. I don't know if that's answered your question, or whether, Max, you want to fill in the gaps, because I know I've left some.
I think you're doing. I feel really rude if I would jump in. That's why I'm being quiet. I just nod.
If professors agree among them, that is a premiere today. Then, So Emma, you're going to like the next one, because I know it's an aspect you often discuss, which is the rebound effect. Can you comment a little bit on this?
Yes, so there's I see lots of different rebound effects. Firstly, if you you dematerialize an activity through technology, so it can lead to rebound effects. So a classic one, and it's all about where you set your system boundaries. So a classic one would be, okay, I've got super fast broadband, I will now telework. I don't have to travel into the office. And the rebound effect would be that. So you save a lot of fuel or and time and all the rest of it. The rebound effect would be perhaps that you then use more carbon heating your home, or that you decide to move further from the office. And then when you do go to the office, which might be say once a week instead of every day, you're outside a public transport system and you then have to drive and it's much further. So that would be a rebound effect where the net impact actually isn't positive because you've dematerialized one aspect of that. So you have to work out where you set your system boundaries. The other one that I brought up, which is the Jevons Paradox, is a much more fundamental rebound problem that we have, particularly with the internet provided services. And it's this incredible chase for efficiency, which the sector has done an amazing job of. We're amazing at operational efficiency. We've within the sector, I think the amount of energy it takes to process a given amount of data has reduced by 7 orders of magnitude in about 3 decades. It's absolutely incredible. So if you applied that to a jumbo jet, I think you could fly a jumbo jet from London to New York on the fuel equivalent of 3 teaspoons of cough medicine. Now that's a very bad comparison for many reasons, but it just shows you the scale of improvement. And of course, what that means is it's driven enormous demand, and the demand it's driven has way outstripped what we, it's just going much faster. And a guy called Jevons modeled this in the UK many years ago with coal. So I'd say we have both these problems, and we've got to work out, as the fundamental challenge for data centers is how we accommodate this huge growth in demand for digital services without this parallel explosion in energy consumption of the sector. And as I said, we're doing pretty well, but again, it's not run by magic. There are physics involved and there are limits. So that's what we've got. I'd say that's the biggest challenge for the sector.
Thank you, Emma. 2 final questions before we take a quick coffee break, but I warn you, they're not necessarily simple. There's someone asking about why are we not adopting, I don't know who the we would be, why are authorities not adopting so-called Pigovian taxes? Pigovian taxes, I had to verify myself, are those taxes that internalize the externalities of what it is being taxed, in this case, of data centers. So I think if you're aware with some of them, that could be the occasion of speaking a bit about taxation of data centers. And I know of some examples in Europe that could be relevant, but I'll leave you the first jab at this one. And then a final question about C-level management in the data center industry, or more broadly beyond the data center industry. Are they aware of those questions? Do they take this seriously, and are they personally engaged in those questions? So the taxes and the CEOs.
Okay, so I'll start with the CEOs because they're easier. And I'd say absolutely resounding yes. If you look at some of the activities going on at voluntary level, they involve an astonishing number of C-suite individuals. So I think it's being driven very much from the top. I don't think that was true 10 years ago. I'm not sure it was even true 5 years ago, but it's a real, and there's a lot of people wanting to take leadership roles in that. So I'd say it's very much front and center. But I think that's probably within the last 5 years that I've seen that happen. So that's good. Taxing data centers is an interesting one. In the UK, we sort of did the opposite. I would like to be taxing inefficiency. So I'd like to say what we want to do is use taxation to improve performance. And in the UK, we did the opposite of that. We used, and we still do, we had a tax incentive so that if data, and I know this happens in other countries as well, if data centers met certain quite demanding efficiency requirements, they would get a small tax rebate. Now, when you use a lot of energy, a small tax rebate on energy is significant. So it was a huge incentive. And we saw over that about a 30% improvement in infrastructure efficiency over the 10 years, the first 10 years of the scheme, which is non-trivial because the infrastructure bit is the hardest bit to make more efficient. And that's what it was targeted at. Pigovian taxes, again, I would have had to look that up, so thank you for explaining. And how you internalize the externality, I think, is really tricky. And I probably wouldn't know where to start with that. So I'm glad we've got policymakers on board who can do that clever stuff, because I really wouldn't know where to start. But I have seen, tax incentives being used very successfully to improve efficiency, but I don't think they will actually solve the externality problem. That's going to require some thought.
Good. So it looks like after grilling you on every possible question, taxes is the place where we managed to. Emma, that was fantastic and extremely insightful. And you're the second frank speaker of today. So that puts the burden on Miguel and myself for after the coffee break. To the ones who asked the questions that are still open on the chat, there's 2 questions about legislation that I'm parking for myself, because I think my pitch and later on will be best suited to answer them. Emma, thanks again for your help. Everyone, it's 11:07 on my watch. This is not a conference nor a workshop, so grabbing a mug and stretching legs can go fast. We'll start again at 11:12, so in 5 minutes from now, okay, with Miguel and then myself until noon. Thank you very much and see you in a minute. We thought it would be very interesting to have the perspective of someone actually doing the work, because Max and Emma and myself, I think we always have an answer of, yes, we've seen this here, yes, we've seen this there, yes, it's possible, yes, it's feasible, yes, we're investigating this and things like this. But at some point you need to become practical and do the work and face the hard limitations of the real world. So we thought all together that it would be very interesting to have someone like Miguel today to walk us through what it takes to operate a big and world-class data center, obviously for our own needs. So there's no commercial offering, but it's nevertheless a state-of-the-art data center that we have inside of the Commission. Miguel, the floor is yours.
Thank you very much, Manuel, for the kind words and for the nice introduction, and good morning to everybody. I will try first to make it difficult to guess whether I'm an IT geek or not by trying to share my screen. Hopefully it should be working by now. Is it?
Yes, it works.
Okay, that's great. I hope audio and video are also nice. So let's go for it. Well, actually, with your kind introduction, Manuel, you spare me some introduction of who we are and what we do. Thanks God, I'm not alone in this, so I'm in the good company of several hundred people to try to run our corporate data centers. And I would start with the original name of the conference. That was the Roman concrete walls of data housing. I thought it would be nice to start comparing how buildings were built some time ago by the Romans. You have in the picture a well-known building, and you will have in the next picture a not so nice building, I would say, where we are hosting our IT equipment, our data center equipment. So if you compare both, well, it's obvious that the purpose is completely different. It's obvious that the construction technology is completely different. But we must recognize that the building of the Romans have stood for 2,000 years. And well, it's not so clear that these buildings will stand for so long. In any case, as you may see, they are not so beautiful, so who cares? Let's have a look into the reality. So I'm trying to share with you here a sort of X-ray of how a real DC building looks like in the interior. So the first idea to take away, and if you pay attention to the picture on the lower left, you would see that just a fraction of the actual surface of the data center building is used for data center rooms where our nice servers are running. And the fraction of this surface depends very much on a number of factors, and I'm going to use just a couple of them. I will try to elaborate. First of all, the availability that we seek for our services, and the second one, the eco-efficiency that we want to have. So as I said, I'm going to try to elaborate on both axes, starting with the availability of the services. The availability of a data center is in general a very complex question, especially because as a user, you want to use this kind of service, this kind of building in order to provide services. Just having a paper, a contract where the building provider is telling you, okay, I'm guaranteeing you a 99.99% availability is very nice, but it's not enough. We need to make sure that the setup of the building, the design of the building is according to this guarantee. And as it happens for many other matters in this world, the certification mechanism kicks in. So you may see that some 25 years ago, the Uptime Institute established an easy-to-digest classification of data centers that can be used by the different actors in this business to know what kind of availability guarantee they need. If you see in the picture, we start with a very basic one. Is the Tier 1, so-called Tier 1 data center that offers the lowest of the guarantees. And if you go down to the one that offers the highest one, is the Tier 4 data center. This last one offering typically the 4 nines guarantee or even more. Well, obviously you can guess which one is the cheapest and which one is the most expensive to build or to rent or to maintain, because certification, as you may guess, is not something that you get forever. So it's a periodical task. If you want to still announce your data center as a Tier 4, you need to be continuously certificating that this is still the case. And as you may guess, of course, this activity allows many auditors to run their business. Let's speak a bit, and here in this slide, I'm trying to share with you some basic generic setups in order to add redundancy to a design. So in the upper one, you see a simple active-passive design where you have some protection in case the active one, so the bold green there, fails, so you still have an alternative. You can go also for 2 active setups. So in case one of them fails, you still have the other, and normally the impact should be minimal. Or you can go for the Rolls-Royce, if I may put it in those terms, making a combination of both, where you can have multiple active fits, each one of them with its own protection. This is important, and you should not think of this just for the business continuity itself of the services you are offering, but also very important for all the operations that are to be run inside the data centers. Because of course, if you want to test your electrical installation or your cooling installation or anything, probably you will need to shut it down, and your customers will not be happy with that. So you need to ensure the business continuity at the same time that you can also do your maintenance operations. Let's see a couple of examples of this. And I have put here the electrical redundancy, and I have also put another example of redundancy linked to the networks tab. So in the lower left, you may see that, as Max mentioned before, we have more than one utility provider. So just to make sure that if one of them is miserably failing to provide electricity, we have a second one. We also typically put inside these buildings diesel generators, so that in the worst case, if both utility providers fail, we still have a plan C in order to continue providing services for at least a couple of days, let's say. We have very beautiful batteries and power distribution units to make sure that the quality of the electricity that reaches the servers inside the racks is good. And of course, all that through two independent physical paths, the red one and the blue one, that at the end reaches each one of the servers inside the racks. If we have a look to the network part, here what we have basically, and sorry for the for scroll, it was too fast. Similarly to what we do with the utility providers, we also have two carrier services providers. So let's call them internet providers, because these will be the gates to the data center, to the outer world, and vice versa. So here, basically, what we are doing is putting a couple of switches in each one of the racks, then putting a couple of switches in each one of the rows of racks, and then having also a couple of switches that interconnect to both carrier providers, so that in case one carrier provider is failing, you still have the second path. If a fiber is cut here, you still have the second switch, and so on and so forth. So at the end of the day, it's always the same idea: having a plan B, having a plan C, etc., etc. And important also to consider that you cannot simply focus on one of them. So having a very fantastic electrical redundancy is very nice, but if your network design is crappy, at the end you can end up with your fantastic servers completely isolated from the world. So they will become basically useless. Let's jump now onto the second axis, so the eco-efficiency. And I would like to share with you all here the European regulation that the Union pushed through by 1993. This basically provides a framework for an eco-management system and an audit environmental scheme that comes along with it. I have also added a couple of ISO standards in case you want to deep dive into these matters. But as we want to lead by example, we have fixed for ourselves some nice targets for 2030 in order to make all our data centers in the European Union carbon neutral. This is obviously a challenge given the growth that Emma and Max mentioned before. In any case, there are some things that are obviously in the scope of this in order to try to be efficient and carbon neutral at the end. So dealing with efficient cooling systems, make sure that the electricity that is consumed inside the data center is green, optimizing the energy consumption. Again, Emma mentioned that before. Trying to be as efficient as possible in terms of wasting materials, on recycling the materials. All that should help in order to meet the target by 2030. In any case, we are running periodically audits about the evolution of all this, and that includes ourselves, of course. Why this target to be carbon neutral? Well, because as it was mentioned in the previous presentations, the data centers and the IT in general is not carbon neutral, not at all. And this is the slide that is supposed to impact you all as it impacted me. So I asked the team to come with some statements in order to make you see clearly how impacting the IT world is for the planet. So if you just look at some of the statements there in the slide, you may see that the internet actually, if it would be a country, it would be the third country consuming electricity just after the United States and China. I'm not going to discuss how accurate this is. It could be the third, the fourth, or the fifth. It doesn't matter. But at the end of the day, it's clear that it's one of the greatest consumers of electricity. If we translate this into CO2 pollution, and then I already mentioned that there are ways to make the equivalence between this, actually it's polluting more, 1.5 times more than the worldwide transport system, which is a hell of a lot. In practical terms, from a user perspective, you can see that apparently there are 12 billion mails sent every hour worldwide. That would need the equivalent of 18 nuclear power plants in order to be able to cope with that. So think about all the nice spam that you receive in your mailboxes and how many times you do reply all and forward to many people, because that's part of it. If you think on surfing, 140 million Google queries are executed every hour, also worldwide. Each one of them emitting, according to this study that I mentioned there, 7 grams of CO2. So you just need to do the math to see what this represents in terms of pollution, between quotes. On top of that, obviously, you need to add to the cocktail the Instagram, the Facebook, the WhatsApp, the YouTube, the Netflix, everything you may imagine, and that was before mentioned also by Manuel in one of the questions. So at the end of the day, we are really using and abusing all the IT in the world, maybe not in an efficient way from a user perspective. But is it possible to stop all this? Probably difficult, even if there are efforts, and there will continue to be efforts. So the best thing that we can try to do is to optimize the energy that we consume inside the data centers. In this pie chart, you may see that in a legacy data center, not all the electricity that enters is used for the IT workloads. Actually, that could be roughly half of it, and the rest of it is consumed by other equipment, including the cooling, the ventilation, the different electrical equipment, the lighting, etc., etc. So even if we are not able to diminish the red part, to make it smaller, we can try to make smaller the blue part. And how can we do that? There are obviously different ways, and I very much appreciate that Emma before repeated that everything works on physics, because that's pure reality. If there are physicists or mechanical engineers amongst the audience, please bear with me. I'm not going to give you any lessons on the possible minus and plus sicknesses that you may see here. I'm not going to make a difficult reading out of this. I will simply say that in general terms for everything in life, if you want to make a work, and the work is represented here by the W, you need the energy, the green thingy, and you are going to sweat for it, the Q. This is the heat, and this is applicable to everything. For those who know a bit more, well, you can easily identify this with the first law of thermodynamics, or the principle of conservation of energy that so far for centuries, no one was able to deny or prove contrary. So obviously this is also applicable to our finest microprocessors that we have inside the data centers, working day and night, not stop. And even if the heat is just another form of energy, it's not the kind of energy that we need or we want inside the data centers. basically because our microelectronics start malfunctioning when the temperature rises above a certain level. So if we want to go together with the need of performance and the grid aspect of all of this, we have to focus on two things: make the energy we consume green, and try to get rid of the heat inside the data centers in the best possible way. So I'm going to share with you one of the possibilities, because there are many, in order to get rid of the heat. The one that we are using in our data center is based on buildings that have the airflow design of the building as the main characteristic of it. There are, of course, other possibilities, but in this case, basically, what we try to do is to get rid of the hot air that comes out of the equipment from all the servers that we have in the data center. Push it out and make it go to the heat exchanger. In this case, it's a Kyoto wheel that actually is cooling down the air and then injecting it down to the data center itself. By this way, and it's to some extent impressive how efficient this could be. So I could give you some example that is close to what we have. The data center building provider can ensure you that as long as the temperature outside, in the environment outside of the data center building, does not go above some, let's say, 30 degrees, inside the data center, they can guarantee that the temperature of the air will not go above 22 degrees centigrade. And this is temperature that our microelectronics can live with. They can work at this temperature. So that's pretty decent. Obviously, as you may imagine, by now, the cool air inside the data center is a precious asset. It's something that you need to protect and you need to use in the best possible way. So if you look at the two similar figures on the right hand side of the slide, actually what we want to avoid is to allow the cool air to mix with the hot air before entering the equipment, because if that happens, the cooling of the microprocessors will not work properly. They will heat up and they will stop working. That's a problem. So the closest we can get to the right one is the best thing we can do. And in order to do so, there are a couple of things that we are doing, which is the first one is building what we call cold and hot corridor, or aisles, so that the cold air is guaranteed to be efficient when entering the servers, so that the fans from the servers are going to pull the cool air inside the cases, refrigerate the processors, and then the hot air is coming out of the racks, and due to the air design of the building itself, it goes up to the Kyoto wheel where the heat exchange happens. Even in that case, another thing that is important, because, well, you can isolate corridors, but still you need to push cables through the servers for electricity to power the servers, to power the equipment, to give them network connectivity. So for those cases, we use what we call the brushed grommets, which is a sort of brush that allows passing the cables, but without exchanging heat between the two areas. As I said, there are other possibilities, and you can have a glimpse here on some of the possibilities. The first one is the water cooling instead of simple air cooling. This is more efficient, and you can see that in a very small scale when you have looked to the beautiful PCs of the gamers with very nice lights inside the case, and the circuit for the liquid exchange with the processor. Of course, in the data center, this is basically the same idea, but at a much larger scale. And I have seen several of these. It works. It looks like the work of a crazy plumber because you have pipes all over the place, the red pipes and the blue pipes entering each one of the servers, get into each one of the processors. But it's a bit more efficient than cooling by air. But of course, the setup of the building and the risks you need to take care of are a bit higher in that sense. Some have tried also a very ingenious thing, which is to put a data center on the sea floor, so under the sea surface. Of course, the environment is then guaranteed to be at a decent temperature, so that the cooling inside should be easier. I wonder, however, in case of a defective piece, a defective disk or something, probably there is not much you can do to replace it. So the lifespan of this kind of solution may be shorter because it will degrade in time. But if it is redundant enough, as I said before, it could last for enough time to make it useful. The last possibility I have put there is just to put a data center on ice. And this looks nice, but obviously it's only feasible if you can put it near the Arctic Circle, where the temperature is cold enough. And yeah, it will give some heat to the outside. That is not precisely what we want, but it seems a bit easier to work in case of issues. Finally, I will end up with just a picture of one of our data centers. So this is a real one, where you can easily identify the open hot corridors, and you can see the doors in the middle of the racks that give access to the cold corridors. So that's how we isolate them. You can also easily identify the yellow thingies above the racks, how the power is distributed through all the racks. And I have also added a couple of references that Emma mentioned before to the European Code of Conduct. This is an initiative that was sponsored by the Joint Research Center of the European Commission, so you can find a lot of stuff there. And also the other one that Emma mentioned, the Climate Neutral Data Center. This is a self-regulatory organization where most of the data center providers are present, and they put conditions there in order to be a member. They commit to some of the measures that I have mentioned here. So I think that's it. There will be enough time for questions. So thank you everybody for your attention. And Manuel, back to you.
Thank you very much, Miguel. This was admirable and insightful, and gave rise to quite a few questions. And again, there's a couple that I've parked for me, but there's a question about the certification and audits. Can you briefly tell us, in our case, the commission data centers, what type of certification and auditing happens in reality? And provided you're aware of it, what other alternatives exist out there? And I think the person asking is in particular interested in knowing whether they're rather European-based or American-based, or maybe it's simply relevant and the data centers are the same on both sides.
Yeah. So well, the first question is easy. So we think that our business is really important. So we want to have a very redundant data centers. So our data centers are tier 4, according to the classification that I showed in the previous scheme. Now, in order to understand the certification process, actually we are using providers of DC buildings. These are specialized buildings that are built by a good number of companies. But the full building is not devoted to ourselves. So there are other customers inside the same building. Even if we have our own DC rooms that can only be accessed by ourselves and by the technicians that we authorize. And so the certification process is actually the building landlord who goes through it. and they obtain from the different companies this the renewal of their certification according to the level. So if during an audit the auditors find some things that are not coherent with the mechanisms that are required according to the Uptime Institute for each level, then they do not get the renewal. So they are the first interested in doing things right, so that they can continue marketing their data center buildings at a certain tire level. It's important to mention that it's not only the build that is audited in those cases, so the design of the building itself, but it's also the processes that the landlord need to accomplish during the whole lifetime of the data center building in order to make sure that the building is according. So, for example, testing the diesel generators, testing the electrical installation, so shutting down one of the feeds and leaving just the other to see what happens. That kind of test is what they are obliged to do in order to continue having the certification. I don't know if that answers the question. I hope so.
Yes, I think it does. And it does, Miguel. Thank you very much. Another question about the pandemic. What type, and I think this goes a little bit beyond the green, but I think everybody will be curious of that. How did the pandemic affect the activity level of your data center, Miguel?
Well, to a good extent, in some aspects, not in all of the aspects. Let's say that for us, the main impact beyond hosting the COVID certificate exchange between member states, that was one of the information systems that we were hosting there, that we are still hosting there actually. The main challenge at the time was to pass from a situation where everybody was in the office to a situation where everybody was working from home. So we had to multiply the efforts in order to have enough capacity in terms of bandwidth, for example, in terms of processing power, in terms of remote access, so that the 40,000 people that is normally working, or roughly 40,000 people working inside the European Commission, were able to work seamlessly as if they were in the office, where we have our internal network, but the connectivity to the outside world was not obviously as powerful as the internal network. So we had to level that in order to make it transparent as possible to all our people. For the external world, in that sense, probably they may have seen an improvement in terms of performance. But I think the performance was already there before. So you need to be very sensitive to that in order to realize.
Yeah. Okay, good. Thank you very much. Maybe a question which is extremely broad, but I'll narrow it down for you. In your particular case, the question is about energy prices at the moment and the energy crisis in general in Europe. How does that affect you on a day-to-day basis? I mean, is it simply the bill of energy going higher, or are you doing things to adjust our consumption because of this?
Yeah, well, Emma already mentioned the look for efficiency. This is something that we have improved a bit, and I would like also to remind what Max mentioned about the different steps, the ritualization of the data center services, then the next step to containers. Basically, what we try there is to be able to have as much utilization of the server's capacity as possible, and not just to assign a server to a physical server to a specific client and another physical server to another one. So that's one aspect. In terms of bill, of course, it has an impact, and thanks God I do not have to pay for it because it's an expensive bill. We have not seen so far any issue in terms of power provision. So far, I mean, all the electricity that we consume is green, so we are not impacted by the latest problems with gas supply in Europe, let's say. Where we are being impacted, and I would say heavily, it's not deadly, but heavily, is in the provision of equipment. So the lead times that we have now to receive the equipment that we order have really gone far from what they were before the COVID crisis. It's well known. I mean, the scarceness of materials, the scarceness of components, and this is impacting also all the equipment manufacturers for servers, for storage equipment, etc., etc. This is where we do really see the difference.
Oh, so it's an interesting insight. Aside the bill, energy crisis is under control, but you're still feeling the logistics aftermath of the COVID crisis.
Absolutely.
That's very interesting. Miguel, thank you very much. I unfortunately have to turn off the question flow now. I'll try to pick some of them in my very final remarks, but I would like now to turn to myself to bring the listeners to our dear students to give them an insight of what the Commission does in to address all this technical situation that has been depicted by the three previous speakers. Let me bring up my slides, and obviously I usually start by presenting a lot of not so well of what the three previous speakers have done, but let me focus only on what the Commission does. This is a study that we conducted and that was quoted at least by Miguel, but I think in other words as well by Emma and Max. This is a study that we conducted a few years ago on the energy consumption of data centers and how it evolves. And you see that the amount is what it is, but I think what as policymakers has a big influence on our will to move things is the difference in between the red and the green line, which are different scenarios on how do we go about it. I mean, if you look towards the end of the decade, the difference in policy making has about three times three orders, not orders of magnitude, but three times the effect. There's the brown line, which is very interesting, and it has been brought up by different questions earlier, which is the edge, the move from very, very centralized large data centers, as roughly today, to more distributed edgy data centers, so where the computing power is closer to the user. And you see that the blue it's a bit higher, but it's not dramatically bigger than the blue line, which is a bit the baseline scenario. All good policies start with an objective, and this is ours. It's to achieve climate neutral, highly energy efficient and sustainable data centers by no later than 2030. So of course, this is fully in line with the Green Deal initiative, and it's one of its sublines. I think the energy efficient we've discussed today. I think the highly part is something, of course, fundamental, because all of them are somehow energy efficient. And I think it's very interesting to understand that if all the efforts and the progress that the previous speakers have mentioned it's as well have happened, it's as well because it's for once there's not that many areas in the environmental policy that coincide. It's this coincidence in between the interest of the operators and the environmental objectives. It's in the interest of the operators to be energy efficient, and that has driven a lot of their response. But as well, it triggers the fact that there's always policy things to do, but it's the mandatory character of the measures is not that obvious. There's a word of sustainable which is often I don't know if misquoted, but is used and in many different situations. And I think here it has two dimensions to which I will come back in the subsequent slides. Is how do we do that for the material that comes in and comes out to be more sustainable. And it has the aspect of water, which was mentioned earlier as well. So this is not liquid cooling. The water is about cooling the heat that is generated. And it's something that is sometimes abused in some processes, or rather where the focus in between energy and water consumption has been put on, let's save energy at the expense of water, while other processes are more balanced altogether. Oh, I'm facing the, yeah, here it is. So those are the headlines of the things that the Commission does all together. Let me quickly go through them. We have an eco-design regulation on servers and data storage products. This looks at the, if you want, components and machines inside of the data center. So it's not necessarily, it doesn't look at the data center altogether, but it's really looking at the components. It's mandatory, meaning that it's something that everybody needs to abide, and not only the data center industry, but if you're simply purchasing a computer, you will be, the ones who sold it to you are subject to it. It's a fast-paced environment, the one of those products. So it's a regulation that is on a fast pace to be updated every few years, and there's currently, so the current one is from 19 and should soon be updated. I'm not entering the details every time of the timelines, etc., but there are links that I've added to the slides where you will be able to look at the details. Then there's the EU Code of Conduct. I think that is the most known and the one that has been mentioned by everyone. It's I think a 2008 Code of Conduct that is now updated on a yearly basis. It's you could call it a compendium of recommendations. It has 100 of them, where so there's a lot of people drawing experience and insight of what can be done to improve their data centers. Some of them have decided to go further and adhere to the Code of Conduct in a more formal manner, in which case they need to have their data center, they need to report on how their data center performs, and if so, they're allowed to reuse the logo, etc. And Paolo Bertoldi, whose little picture appears there, is the colleague dealing with that in the Joint Research Center since many years, and very relentlessly. We have the taxonomy regulation, which is how do you as a company can justify that your data center is a green investment in a financial context. So this is for example, when a company wants to expand their operations and need to acquire extra capital, and they, for example, issue green bonds for that. There's a conditionality associated to the fact that you call your bond a green bond, to the fact that your investment is green. And this taxonomy regulation has a chapter dedicated to data processing, hosting, and related activities, and actually links to the Code of Conduct. So if you're Code of Conduct compliant and this needs to be audited, then you can claim your investment to be green. In the green bonds, as I said, but as well in your annual financial statement and non-financial statements. There are green public procurement criteria for data centers, server rooms, and cloud services. This is criteria. I mean, it's called criteria, so I left the word, but it really looks more as a template of that the public sector can use when they procure such systems. It's public, it's translated in every language so that member states can reuse without having the need to retranslate this for their own purpose. There was a question earlier, which I don't have in front of me, but whether there's additional ones which are under development. You see that there's one on computers, monitors, tablets, and smartphone, which is a bit more recent. I'm not familiar with others in the same area, so you would have to follow there, and you see there's an ample menu of things going on in that area. There is the Waste of Electrical and Electronic Equipment Directive, which is a directive that deals with the prevention and reduction of the environmental effects of the materials used in general in electric and electronic equipment, but of course the data centers being large consumers of such material are concerned by this. They are concerned up to some extent, in the sense that the burden is typically on the polluter, and the polluter in this context is considered to be the producer, not the user. Yet there are quite a few data center operators who produce their own servers and equipment, in which case they are themselves subject to the WE framework. So this is why it's mentioned here, and so it applies or not depending on what the data center does. Interestingly, this piece of legislation, which dates back to several decades ago, so it's far from being new, is currently under evaluation, and so you will see all the details in this link. There is the Energy Efficiency Directive, which is the famous kid on the block at the moment, because it's currently under review. There's a Commission proposal a year ago from last summer, July 21. Data center, as the rest of the industry, was concerned by the Energy Efficiency Directive, but it now has, in the Commission proposal, a few specific provisions that would force data centers above a certain threshold to share, to get audited and share in a transparent manner, so open to the public, their energy performance, the energy performance of their data center. It's currently under negotiation, so there is as well a council and a parliament view that elaborates on the Commission proposal, and the negotiations, the final negotiations in between the Council and the Parliament in the presence of the Commission, and that's why they're called trilogues, are about to start. So I can explain you the Commission proposal, but do know that there's two other elaborations from the Council and the Parliament over that initial proposal that are out there, and the provisions of the data centers are not the same in all of them. But I think, I mean, looking at this from an optimistic point of view, I think the Council and the Parliament are elaborating over them and have not called to reduce or remove them. So it's more a question of finding a common landing spot than of questioning their existence. This is the one that drives the news cycle at the moment. Then I think it has become very clear from the previous speakers where this is an area which is far from being technologically stable. I put here two studies that my team conducted in the last years. The one on the left is the one that gave rise to the slide that with this energy projection over time. The second one informed a lot of the ideas that went into the review of the Energy Efficiency Directive, but those are just the headlines, and the two studies are each 200 pages and full of details. There's more to come. We keep studying this for our own needs, and but we are heavy consumers of third-party studies, and this is far from being over. And finally, this is policy making beyond regulation, funding instruments. And there was a question about this in the chat. So why is Europe not putting its money into this? And the answer is we are. Earlier, Emma replied about the UK, but there's quite a few countries, I know for sure, France and Sweden, but very likely many more, that have schemes of incentivizing through taxes or things like this, investments in green as opposed to normal data centers. We do the same throughout our funding instruments. In the Connecting Europe facility, we finance connectivity, and this is one dimension. In the digital program, which is about deployment of technology and rather software, the environmental considerations are key. Horizon Europe does research in a lot of research on low power chips, which one can easily understand the effect it has on the overall data center. And then the recovery, the resilience facility, and InvestEU, and that's why I left 3 dots there. It's because there's more to it than that. All the things that I mentioned earlier, we're trying to reintroduce them. So for example, the recovery and resilience facility, which are those funds to reignite the European economy after the COVID crisis. We've made compliance with the code of conduct as a prerequisite, or that one, or the green public procurement criteria in case of public procurement. And so it's a little bit this philosophy that we're using throughout our funding instruments. So with that, this is the end of my own slides. It's really a snapshot. It's the 10-minute version of what me and my team do for breakfast every day. What I'll do is, so usually I was reading the questions while the others were speaking. Now I need to catch up with the questions. What I suggest is we take until 10:12 to do a final round of questions. I'll take them as they come. Alexandro will remove them as we go, and I might call on the other speakers if they're more relevant. So the first question from a colleague, Matteo: in a geopolitical very dynamic condition, I was wondering if our EU data centers are adequately protected in the case they become controlled by non-EU countries. So this is an excellent question. This is not environmentally related, so I'll keep it on particularly short. The short answer is yes, there is something called the FDI regulation, Foreign Direct Investment Regulation, that looks into this dimension. And so me and my team are very often called upon on that to answer that question. Is a new green public procurement criteria planned also for digital networks as for data centers and cloud services? As I answered that earlier, I'm not aware of it, but please look at the link that I provided. I haven't been able to verify for it. Can we envisage a fully first renewable powered EU data centers with redundant electrical power supply, or is it science fiction? I think, correct me if I'm wrong, but this is already the case in some facilities here and there. There was a Horizon Europe funded data center on the small scale, I believe in a Nordic country, I'm not sure where it was, maybe Sweden, where this was done. So I think it's already the case. Are the same cooling methods used for data centers also used in smaller scale edge nodes? I believe so, but I think the efficiency is not, I mean, the smaller size doesn't necessarily allow for the same full-scale deployment that you see. I've heard engineers arguing and counter-arguing. I think there's an easy argument to be made that with scale, you can allow yourself to be more, to invest in more things and to make it all together more efficient. But there are out there as well people arguing that the distributed nature of edge would, for example, simplify the waste heat reuse. There was a question that disappeared by now on the reuse of waste heat, and I think the answer is waste heat can be reused and is often reused, but not systematically. Sometimes because the data centers are simply too far away of, for example, a place where the electricity could be immediately reused, or the heat could be reused to warm a house or a set of buildings. The difficulty as well is that, and I hope Miguel will nod, but data centers tend to produce a low-grade waste heat. So it's rather hair at 40 or 50 degrees, while the ideal waste heat to be reused for heating purposes should be a liquid water at 80 or 90 degrees. And so it makes it it's a low-grade heat that is generated, so it makes things complicated. Thank you for the nod. And as well, there's a counter-seasonal effect in the sense that data centers need to be cooled in summer when the waste heat is actually not needed because it's summer. And you would hope to have waste heat in winter when actually the data centers are not generating that much heat. So I think those things make things complicated, but the Energy Efficiency Directive foresees that new provisions for data centers in terms of waste heat. So I think that's definitely an avenue to pursue further. But I think as well from what Miguel said earlier, maybe it was not explicit, but it was very implicit, is that retrofitting existing data centers is terribly complicated from an energy, from an investment and engineering point of view. And sometimes, for example, for waste heat, it requires adding a set of extra pumps and extra heat exchangers that overall not always justify the, even from an environmental point of view, the investment. So those are a few elements. There's a question on bespoke legislation and the segmentation of legislation. Yes, that's the whole point of the single market in Europe for the last 30 years. This is what the Commission day and night throughout sectors is trying to achieve. I think in the data center industry, we're not doing too bad in the balance of what is European and what is local regulation. But it's something to be always vigilant about. The idea is that we keep a very close eye on what member states are doing. And for example, this idea of a registry of data centers energy performance is something that Germany is currently doing, and one can imagine that if Germany and then another few member states do it on the different criteria, it would become complicated for operators to adjust. So this is just one example where a European approach makes sense. So I think with that, I need a sip of water. Maybe a final question to anyone. Did I miss something, or were you burning to reply to anything? Let's do in the same round that we talked. Max first.
Yeah, I will jump into the what in German we say Fettnäpfchen, the bowl of fat, because heat recovery has been has been one of the first topics that the SDA started with. So I can't help but say there are solutions to the problems you just described. I think there is many data centers, or a few data centers now, there's never many of them, that are using underground heat storage, right? So RTES systems, same as greenhouses actually, especially in the Netherlands, to store the heat. And I think given the reliance of the heating sector on fossil fuels, just by design, I think any such form of such reliable source of waste heat, which is nice in the data center, is that it's relatively continuous. So it is relatively predictable, it's relatively continuous, and storing that heat, in my opinion, at least makes a lot of sense. And I think it's worth the additional effort, especially if it's near cities. But that's it. You are completely right that it's a very, very technical discussion that one always gets into here. But I just to say from a more generic perspective, I think it's worth considering.
Thanks a lot, Max. And so that's a homework for me to go back to this underground heat storage, which I'm not familiar with. Emma, any compliments to all those questions?
I think, yes, and actually I probably pick up on the same questions, Max, just to say what I've heard back from the industry. And there's certainly the issue has been lack of off-takers, as I'm sure Max knows, people who are customers of that, and certainly in many areas the lack of heat networks to receive it. So if we can solve that, that's huge. The other thing that the operators told me, and as I said, as you've discovered in this, I'm not technical, so this is just secondhand, is that theoretically the nirvana of this would be if you were collecting and taking all the waste heat off site, you could dispense with a huge amount of cooling equipment, plant and infrastructure and associated energy. Now, if you can do that, that would be amazing, but you have to have a 100% reliable offtake, because the minute someone says, oh, actually, we're going to just go and revamp the heat network, so we're shutting that down for a bit. If you can't, then the data center can't go because it's immediately going to overheat. So that's what I've heard coming back from the sector. I don't know if that's borne out in technically, but it does sound logical to me. So that's what I've heard saying. So if you could make it 100% reliable in terms of the off-taking, then you could dispense with more infrastructure and improve efficiency within the operations.
Thank you very much, Emma. Miguel, a last word on waste heat or something else?
Well, maybe I would like to make a small mention to one of the challenges that all the companies and all the entities are facing by trying to use public cloud providers, as it was mentioned at the beginning, so hyperscalers or not, in any case off premise, together with data center facilities that are on premise. This comes with some challenges, and the main one probably is linked to the data distribution and the data interaction between the different locations. So there were a couple of questions in the Slido chat asking for the localization of the data. Yes, data ideally should be as close as possible to the where it's processed, and that's why edge computing, as Emma mentioned before, makes sense, especially when you need a very fast reaction of the system. So cars that are self-driving themselves should not go to the other side of the globe in order to have a reaction. But still, there is no real standard in order to move data around between the different data center providers, whether they are cloud providers or not. And there is a thing that I think it's important that is coming, which is the data virtualization, that allows precisely for this kind of exchange and somehow reduces the captivity of the organizations towards a specific data center provider. I think that's an arena that will be interesting in the future.
Yeah, thank you very much, Miguel. And I think that's the beauty of good teachers, is that they open the students' mind to other problematics. And I'm sure Alexandru is taking note of the question of data sovereignty and data distribution. And this is another part of my team works on this, and it's a fascinating discussion that brings up many different policy angles. So I think on substance, this was it for me and for us. 2 rounds of thank yous. First to Alexandru for his admirable setup and patience in having all of us today on board and for the overall organization that was brilliant and smooth. Max, Emma, Miguel, it was a true pleasure. Maybe only the only darker note was not to see you face to face around the table, because I'm sure we would have had a great side discussion and a great lunch afterwards, but that will be for another time. And dear students, you have an hour 45 to go for stretching legs, a bit of jogging, a quick lunch. And at 2, we're starting again with Web 2 versus Web 3 towards the next generation internet, and other colleagues entertaining you on that dimension. So thanks a lot to everyone, and see you very soon.
Thank you.
Thank you. Bye-bye.
Exactly. Thank you, Manuel. And indeed, we wait everyone on the next session where we will actually treat web sovereignty and data sovereignty. And if you aren't able to come today, we also wait for you tomorrow on the sessions on HPC and quantum infrastructure, as well as the one on industrial platforms. Thank you, everyone. See you soon.